Descriptive Statistics. This topic is a part of Biostatistics and Research Methodology in pharmaceutical science. Content of this topic includes Introduction to Descriptive Statistics, Frequency Distributions, Measures of Central Tendency, Mean, Median, and Mode, Measures of Dispersion, Range, Mean Deviation, Standard Deviation, and Variance. Descriptive statistics produces descriptive data, which are summaries that describe the main features, patterns, and characteristics of a dataset, making large amounts of raw data understandable without drawing broader conclusions about a population. Definition of descriptive statistics as the branch of statistics concerned with the summarization and description of data is called descriptive statistics. Descriptive statistics includes construction of graphs, charts, and tables, and the calculation of various descriptive measures, such as averages, measures of variation, and percentiles. Types of descriptive statistics. Measures of central tendency that indicate the center of the data like mean, median, and mode. Measures of dispersion, that is how spread out the data is, like range, variance, and standard deviation. Frequency distribution, that indicates how often values occur. Visual aids like charts also common for representation. Raw data, that can be collected from the survey and experiments. For example, the table is showing marks of 173 students. This raw data set contains values of result or observation, but we cannot understand characteristics of raw data set or make any conclusion about this raw data set. If we want to generate meaningful information from dataset, we need to transform the raw data into meaningful distribution. We can generate some meaningful information by class distribution. For example, table of distribution of marks. The number of observations that fall into particular class or category called the frequency of that class. A table listing all classes and their frequencies is called a frequency distribution. 4 stages to generate frequency distributions. First is organized or array. A better presentation of the raw data would be to arrange them in an ascending or descending order, called as arraying of the data. Second stage, discrete or ungrouped frequency distribution. Marks varies from students to students, are called as variables, finds the number of times each value of the variable, that is, finding frequency for a particular value of variable. Number of students against the corresponding marks is called the frequency of the variable. Here, the table showing the frequency distribution of marks of all students. Frequency may better have presented by tally marks or tally bars, which indicate density of frequency. Stage number 3 is grouped frequency distribution. This includes grouping of data into different classes or class intervals. Here, table is created of distribution of marks by designing different classes of marks. Here, the length of the class interval is 5, is called as width or magnitude of the classes. 2 values specifying the class are called as class limits, upper limit and lower limit. Continuous frequency distribution. This is used in data with continuous variables. Data is grouped as continuous class intervals, which means without gap. If we deal with student marks, class interval of previous table is perfect for frequency distribution. But if we deal with students' age, which can be 6.5, 6.3. It is continuous data. So, in this condition, we need continuous class intervals. Example is age in years. Below 6, 6 or more but less than 9, 9 or more but less than 12. Rule of thumb. For frequency distributions, basic principles of rule of thumb, useful to help construct a frequency table. First is to generate type of classes. Class should be clearly defined with a single meaning, should be exhaustive and mutually exclusive. There is no overlapping, so that any value comes to one and only one class. Second, number of classes. Rule of thumb for calculating the proper number of classes. Sturges rule. Have following equation. K is equal to 1 plus 3.322 log of n, where K is number of classes, that is class intervals. N is total number of observations. Let us calculate number of classes for 200 students containing a data set. K is equal to 1 plus 3.322 log of 200. On solving an equation, the answer you get is 8.644. So number of classes may generate is 9. The number of class intervals should be such that they usually give a uniform distribution. That is, frequency first increases steadily, reaches a maximum, and then decreases steadily. The number of classes should be a whole number, that is integer, preferably 5, or a multiple of 5. This is quite convenient for numerical computations in the further process. The third principle is for size of class intervals. Sturges' rule equation is I is equals to range divided by number of class. Range is actually x maximum minus x minimum. X maximum is the largest value of observation. X minimum is the smallest value of observation. Number of class is obtained from previous calculation of K. Types of class intervals. First is inclusive type classes. If both upper and lower limits are included in the class, is called an inclusive class. For example, a table of the distribution of marks of 173 students, we may generate classes as 15 to 19, 20 to 24, 25 to 29. Fractional values between 19 to 20 cannot be accounted for in such classification. Inclusive type classification is used for grouped frequency distributions, where observation gives only integer values. Another type of class is exclusive type classes. Here, class intervals have to be made without any gaps. For example, a table of the distribution of marks of 173 students. We may generate classes as 15 to 20, 20 to 25, 25 to 30. In exclusive form, 15 or more but less than 20 is 15 to 20 class. 20 or more but less than 25 is 20 to 25 class. 25 or more but less than 30 is 25 to 30 class. Exclusive type classification is used for continuous frequency distributions. Descriptive plots in frequency distributions. Ronald A. Fisher, the father of modern statistical methodology, said that diagrams prove nothing, but bring outstanding features readily to the eye. Diagrammatic representation of frequency distribution. Example is histograms. Histogram of table of marks of 173 students is presented here. Measures of center is a type of descriptive statistics. Central tendency is the central value of a data set. Descriptive measures that indicate where the center or the most typical value of the variable lies in a collected set of measurements, are called as measures of center. It is a single numerical value that is representative of the entire distribution. Various measures of central tendency are mean, median, mode, geometric mean, and harmonic mean. First, we start with a well-known, commonly applied measure of center, that is, mean. It is also recognized as the arithmetic mean, and in general, the average. Symbol for mean is x bar. Equation is x bar is equals to sigma x divided by n. Mean is actually sum of the observations divided by the total numbers of observations. An exercise: assay of 10 tablets completed with potency in milligrams of tablets, found as values listed here. Calculate mean. Sum of the observations gives the value 915.7. This is divided by total number of observations, that is 10. On division, we get mean of tablet potency data is 91.5. Another exercise: the data of assay of 10 tablets given below. Calculate mean. Here, data set is same, but given as frequency. The first column includes the values of potency of tablet in milligrams. Second column shows frequency of particular observation, that is weight of observation. In this case, we cannot use the equation of arithmetic mean, or we may use the equation, but it seems lengthy calculation. Here, the data given is in weight, so we are going to use the equation of weighted mean. Weighted arithmetic mean is calculated as the weighted sum of the items divided by the sum of the weights. Equation is x bar w is equals to sigma wx divided by sigma w. By using the symbol of frequency, we have the equation of weighted mean of x bar is equals to sigma fx divided by sigma f. X is potency. F is frequency of tablets. To calculate sigma fx, we need to extend one column of fx. Sigma f is the sum of frequencies. So sigma f is 10. In fx column, we need to multiply the values of x with f of all observations. Finally, sum of all fx is sigma fx is equals to 915.7. Put the values of sigma fx and sigma f in the equation of weighted mean. We will get the answer 91.5. Exercise containing a dataset with a frequency distribution. Assay of 100 tablets is given below. Calculate mean. Potency of the tablet is distributed in 5 classes. So, we need to use the equation of the mean for grouped data. We need to find out the mid-value of the class as x value, and next column need to insert is fx. Sigma f is the sum of all frequencies, and the sum value is 100. Mid-value of each class is identified. Fx is obtained by multiplying the value of frequency of tablets with the mid-value, and then sigma fx, that is sum of fx, is obtained as 10068. Put the values of sigma fx and sigma f in the equation of mean. We get the answer, 100.7. In this solution, we need to calculate fx. The values of fx have 4 digits, double to the digits of observation values. If the digits of observation values are 3 to 4, that is, in thousands, the values of fx reaches to crores. These values are somewhat difficult for further calculation and create more chances of error. To overcome this problem, we have step deviation method. The equation to calculate the mean with step deviation method is given below. A is an arbitrary value. The middle value of x is always chosen as A. H is magnitude of class. D equation is given in right side. Here, we need to calculate D and FD. The values of FD are much smaller than the values of fx. So, these two-digit values of FD are easy for further calculation with comfort. A mean obtained by the step deviation method is same, that is 100.7. So in data set with large values, the step deviation method is useful in manual calculation of mean with more comfort. Next measures of center is median. Median divides the group in two equal parts. It is exact center, middle position, or 50% point. A median is that value of the variable which divides the group in two equal parts, one part comprising all the values greater, and the other all the values less than median. Median is the exact center, defined by its middle position, the middle value of dataset. Median refers to the 50% point in a frequency distribution. Steps to identify the median. First, arrange values in ascending or descending order of magnitude. Then, find the center point of observations. Exercise. Find median for given observations 1, 2, 1, 34, and 3. Step 1 is ascending arrangement, is 1, 1, 2, 3, 34. Step 2 is find center point. Here total observations are 5, so middle point is third one. So median is the value of third position, that is 2. Second exercise, find median for given observations. Step 1 is ascending arrangement of dataset. Ascending arrangement is displayed here. Now step 2 is find center point. As the total observations are 15, the middle position that divides the group in two equal parts is 8th position. So, median is the value of the 8th position. That is 23. When we deal with odd number of observations, for n odd observations, n is equal to 2m plus 1, where m is an integer. The median, then, is taken to be the value of the m plus 1 observation, ordered from smallest to largest. 2n plus 1 values, the median is the n plus 1th ordered value. Exercise. Find median for given observations of tablet assay in milligrams, given here. Step 1 is ascending arrangement of data set. Ascending arrangement is displayed here. Now step 2 is find center point. The total observations are 10. There is single position is not possible as the middle point. We have to include two middle positions. That divides the group into two equal parts. These are 5th and 6th position. Median is equals to arithmetic mean of 2 middle value. So, median of given observations of tablet assay is 91.4. when we deal with even number of observations. For n even observations, n is equals to 2m, where m is an integer. The median then is taken as the average of mth and m plus first values from smallest to largest. Find the median for given observations of number of heads on tossing 8 coins together. Frequency of getting heads is given here. So in this exercise, we have data with frequencies. Steps to calculate median for data with frequency distribution. First, find cumulative frequency. A cumulative or running total is addition of each number in a sequence to the sum of all preceding numbers. So, the first cell of cumulative frequency is same value of frequency. In next lower cell, cumulative value is 1 plus 9 is 10. In next lower cell, cumulative value is 1 plus 9 plus 26 is equals to 36. In next lower cell, cumulative value is 1 plus 9 plus 26 plus 59 is equals to 95, and so on. Second step is to find n divided by 2 value. N is the total number of observation. The last cell value of cumulative frequency is the sum of all frequencies. That means it's the total number of observations. So n is 256, and n divided by 2 is equals to 128. Next step is search the CF just greater than n upon 2. N upon 2 is 128. When you search in the column of cumulative frequency, the value just greater than n upon 2 is 167. The value of CF just greater than n upon 2 is the median. So median of this data set is 4. Next measures of center is mode. The mode is the value that occurs with the greatest frequency. It is the value that is most popular in a continuous distribution of scores. We have previously seen these observations of assay of 10 tablets. Now, identify mode for the same data. Mode is the value with the greatest frequency. In this table, the greatest frequency is 3 for 91.5 value. So, mode is 91.5. Next, exercise. Find mode for given observations. We have to identify the value that is coming with the greatest frequency. When you search frequencies of observations, the value 23 have greatest frequency of 4. So, mode of this data is 23. Graphical representation of observations versus frequency distribution. The mode is identified as the peak of the curve. Normal distribution is found with one peak at middle. It is unimodal distribution. Bimodal mode, found in bimodal distribution. A set of data with 2 modes is known as a bimodal mode. This indicates there are 2 data values having the highest frequency. Multimodal mode, a set of data with 4 or more than 4 modes, is known as a multimodal mode. Bimodal distribution of plasma concentration of isoniazid at 2 hours after the administration of isoniazid 300 milligrams. People with the fast acetylation phenotype showed lower plasma drug concentrations than those with the slow acetylation phenotype. Geometric mean. It is applied on logarithmic transformation. Its equation uses antilog and logarithms. The geometric mean is the antilog of average, of the logarithms, of the observations. It represents a logarithmic transformation of data to calculate the mean. These are the equations to calculate geometric mean. Geometric mean is used when greatly differing values within a dataset occur. The geometric mean is always less than or equal to the arithmetic mean and is meaningful for data with logarithmic relationship. Bacterial population growth over time is given in a table. Calculate mean and geometric mean. When we put the values in equation, we get the mean is equals to 116.6 and geometric mean is equals to 100. There is addition of one observation at 3 hours. Bacterial population growth is 400. Now calculate mean and geometric mean with 4 observations. When we put the values in equation, we get the mean is equals to 187.5 and geometric mean is equals to 141.4. Now compare the mean and the geometric mean of both observation tables. We can see that the value of geometric mean is less diverting than simple arithmetic mean. So the data with drastic change in observation values, geometric mean is more meaningful than arithmetic mean to measure center of data set. The arithmetic mean would be distorted by these extreme values, while geometric mean, an average that's closer to the average of the lower values. Harmonic mean. The harmonic mean is the reciprocal of average of the reciprocals of the observations. It represents reciprocal transformation of data to calculate the mean. Equation of harmonic mean is like flipping of arithmetic mean equation, as n is divided by sigma of 1 divided x. Exercise for the 3 observations, 2, 4, and 8. Calculate harmonic mean. When we put the values in equation, we get the harmonic mean is equals to 3.43. Harmonic mean is of limited application, particularly in cases where time and rate are involved. In normal or bell-shaped distribution, mean is equals to median is equals to mode. In positive skewed distribution, mean is greater than median is greater than mode. In negative skewed distribution, mean is less than median is less than mode. The table contains 3 different data sets, A, B, and C. Now find out mean of all 3 different data sets. For all 3 data sets, there is same mean, that is 9, but there is different distribution of data sets. So, measure of center tendency gives idea about center part of data set, but fails for the prediction of the distribution of data. This arises as limitations of measures of central tendency. Central tendency gives an idea of the center part of the data distribution, but there isn't complete prediction of the distribution of data from the central tendency. Measures of dispersion. Dispersion is due to the variation of observations from about a central value. Dispersion or variation or scatteredness is the measure of the variation of the items. Dispersion is the degree of scatter of the variables about a central value. Measures of dispersion aim to describe the spread of values in a data distribution. Characteristics of ideal measurement of dispersion. It should be rigidly defined. It should be easy to calculate and easy to define. It should be based on all the observations. It should be easy for further mathematical treatment. It should be affected as little as possible by the fluctuation of sampling. Various measures of dispersion. Range, the mean absolute deviation, the standard deviation, and quartile deviation. Range, symbol is capital R. Definition, range is the difference between the two extreme observations of the distribution. It can also defined as difference between the smallest and the largest values in the data set. Equation range is equals to x maximum minus x minimum, or L minus S. Coefficient of range. It is the ratio of the difference between two extreme observations of the distribution to their sum. Equation is coefficient of range is equals to x maximum minus x minimum divided by x maximum plus x minimum. Mean deviation. Mean deviation is the average amount of scatter of the values in a distribution from either the mean or the median, ignoring the sign of the deviations. Equation is mean deviation is equals to sigma of x minus x bar upon n. Standard deviation. The symbols of standard deviation are sigma, SD, or capital S. Standard deviation is defined as positive square root of the arithmetic mean of the squares of the deviation of the given observations from their arithmetic mean. When we use the sample as an estimate of the whole population, SD is calculated as sample standard deviation. The symbol of sample standard deviation is capital S, which is equals to under root of sigma of x minus x bar whole square upon n minus 1. When we study the small finite population, SD is calculated as population standard deviation, symbolized as sigma, which is equals to under root of sigma of x minus x bar whole square upon n. The standard deviation is a measure of how spread out the numbers are. In the equation of sample standard deviation, n minus 1 indicates the degrees of freedom of the sample. N is the number of all possible values in the population. The use of n minus 1 rather than n in the calculation of the variance of a sample makes the sample variance an unbiased estimate of the population variance. This is the concept of degrees of freedom. Exercise. Find the mean deviation and standard deviation of the given results of percent purity of the drug. Its 5 NOS of the sample drug are tested for assay, and the result is mentioned in this table. To solve this exercise, equations we need to use of mean deviation and sample standard deviation are given below. Now, first, we need to identify and calculate the parameters which are present in equations. We need to calculate x bar For this, we need sigma x, and we are adding a column of x minus x bar and a column of x minus x bar whole square. Stepwise calculation. Sigma x found is 515. N is 5, so the value of the mean calculated is 103. Sigma of x minus x bar is 3.4, as we are ignoring the sign of the deviations. Sigma of x minus x bar whole square is 2.98. Now, add all this calculated values into equations of mean deviation and standard deviation. Upon solving, we finally get result as the mean deviation is 0.68 and standard deviation is 0.86. So, mean deviation is 0.68 and SD is 0.86 of the given results of percent purity of the drug. Significance of the standard deviation. Standard deviation is the minimum value of the root mean square deviation. Standard deviation is always less than or equal to range. For discrete variables data, standard deviation is greater or equal to mean deviation. There are 3 datasets. Graphical representation is present here that we had seen previously. The mean ratings are the same for each group. The curve with the lowest standard deviation has a high peak and a small spread, while the curve with the highest standard deviation is more flat and widespread. Variance. Symbol of variance, sigma square or capital S square. The variance is the square of the standard deviation. The variance is the average of the squared differences from the mean. The equations of sample variance and population variance are given here. S square is for sample variance and sigma square is for population variance. Exercise. Small finite population with the blood sugar given below. Calculate range, standard deviation, variance of dataset. The table contains blood sugar value in milligram per deciliter of 5 patients. The equations of range, variance, and standard deviation are here. The maximum value of these observations is 125, and the minimum value is 7. So, range is 125 minus 70 is equals to 55. Now, to calculate variance, we need mean value. We need to calculate x bar. For this, we need sigma x, and we are adding a column of x minus x bar and a column of x minus x bar whole square. Stepwise calculation. Sigma x found is 470. N is 5. So, the value of the mean calculated is 94. Sigma of x minus x bar whole square is 1770. Now, add these calculated values into equations of population variance. We get the value is 354. Population standard deviation is under root of population variance, so under root of 354 is equals to 18.8. So, range is 55, standard deviation is 18.8, and variance is 354 of the given small finite population with the blood sugar. Imagine a population when we take sample and identify mean and perform these 3 times sampling from same population. There may be a slight differences in all 3 means. Repeated sampling would result in a group of means, each composed with different values. This may be seen as error of the mean. Standard deviation of mean. Symbol is SEM or SE, and in mathematical equation, SX bar, synonym, standard error of the mean or standard error. Equation of standard error is equals to standard deviation upon under root of n. Standard deviation of mean is a measure of the variability of the sample means. Standard error gives the accuracy of a sample mean by measuring the sample-to-sample variability of the sample means. It is a measure of chance variation. It is not an error or mistake. Difference between standard deviation and standard deviation of mean. Difference by meanings. The SD is a measure of the spread of a group of individual observations, while SEM is a measure of the variability of the sample means. SD measures the dispersion from specific data points to the mean, while SEM measures the precision of the sample mean. We also note the difference by their equation. The value of SD is always larger than SEM. Increasing the sample size does not make the SD necessarily larger or smaller. It just becomes a more accurate estimate of the population SD, while as the sample size increases, the SEM becomes smaller and smaller. Coefficient of variance, or relative standard deviation. Symbol, CV, RSD, or percentage RSD. Coefficient of variation is the ratio of the standard deviation to the mean. Equation is CV is equals to standard deviation upon X bar. The CV is usually expressed as a percentage, that is, relative standard deviation or RSD. So, equation of percentage RSD is standard deviation upon X bar into 100. In different reference books or other sources, you may see various symbol in this equation. Significance of coefficient of variance. The CV is usually expressed as a percentage, that is, relative standard deviation, or RSD. Absolute variation is the standard deviation. Relative variation is coefficient of variation. RSD of 0.1 or 10% means that the SD is 1/10 of the mean. Applications. To find the variability in chemical and instrumental analysis of drugs allows a comparison of the variability of different kinds of measurements. To find precision in analytical method development and instrumental analysis of drugs. Here is the application of coefficient of variance in HPLC analysis of the combination of drugs. dapagliflozin, and metformin. The RSD is calculated for 6 measurements of metformin. For quantitative assays of active ingredients, the required precision, generally RSD is less or equals to 2.0%, is acceptable. End of the topic of descriptive statistics. You can refer to these mentioned books for this topic: Fundamentals of Statistics by S.C. Gupta, Pharmaceutical Statistics, Practical and Clinical Applications by Sanford Bolton, Basic Statistics, and Pharmaceutical Statistical Applications by James E. Demuth, Introductory Biostatistics for the Health Sciences by Michael R. Chernick. Please take a note on important study questions. Thank you.